Tonight, we're going to ask the largest question it is possible to ask. Not how the universe began. We've wondered about that before. Tonight, we face the other direction. Tonight, we ask how it ends, because it will end. That is one of the strangest and most certain things modern science has ever told us. The universe, this vast, ancient, star-filled everything, this thing that contains every galaxy and every world and every person you have ever loved, is not permanent. It had a beginning, and it will have an ending. The stars will not always shine. The galaxies will not always turn. Somewhere ahead, unimaginably far down the river of time, there is a last day, a final chapter, a closing line. And here is the thing most people don't realize. We don't just know that the universe will end. We know how it might end, and there is more than one way. Physicists have mapped out the possible deaths of the universe the way a doctor might map out the possible futures of a patient, and they have given them names that sound almost like children's stories. The Big Freeze, the Big Rip, the Big Crunch. A slow fading into eternal cold, a violent tearing apart of everything down to the last atom, a great collapse, the whole cosmos falling back in on itself. 3 different endings, 3 different last pages. And the evidence we're gathering right now, tonight, with telescopes scanning the deep sky, is slowly revealing which of these endings is actually written into the fabric of our universe. There is even a 4th possibility, the strangest of them all, an ending that would not wait billions of years, an ending that could, in principle, begin anywhere at any moment and sweep across the cosmos at the speed of light without any warning at all. We'll meet that one too gently, and I'll tell you why it should not keep you up at night. Why, in fact, none of this should. Because that's the real promise of tonight. We are going to walk slowly and calmly through the death of the universe, through fire and cold, and the long silence after the last star. And somewhere along the way, something unexpected happens. It stops being frightening. The end of everything, examined slowly enough, in the dark, at the edge of sleep, becomes one of the most peaceful ideas there is. And by the end of tonight, you'll understand exactly why. Before we set out for the end of time, if these slow journeys through the universe help quiet your mind at the end of the day, take a moment to subscribe and come along. It's a small thing, but it helps these gentle explorations find the others out there, lying awake right now, wondering about the very same things you are. And please tell me in the comments where you are tonight and what the clock says. Whoever you are, wherever you are, you're not the only one awake. That's half the reason this channel exists. Now, let's begin. Let's start with a question that sounds almost naive, but is actually profound. How could we possibly know that the universe will end? Nobody has seen the future. Nobody has been to the end of time and come back with a report. The universe has been here, as far as anyone can tell, for around 14 billion years. So what could possibly make us think this whole grand show has a final act? The answer begins about a century ago with one of the greatest discoveries in the history of human thought. Astronomers, measuring the light of distant galaxies, found that nearly all of them are moving away from us, and that the farther away a galaxy is, the faster it recedes. The whole universe, they realized, is expanding. Space itself is stretching, carrying the galaxies apart like raisins in a rising loaf of bread. And that single discovery changed everything in both directions of time. Run the expansion backward, and you arrive at a beginning, a moment when everything was together, the Big Bang. Run it forward, and you are forced to ask the question we're asking tonight. If the universe is expanding, what happens next? Does it expand forever? Does it slow down? Does it stop and turn around and fall back in? For most of the 20th century, that was the great open question, and it seemed to have a beautifully simple shape. It was a tug of war between two forces. On one side, the expansion, the outward stretch, the momentum of the Big Bang itself. On the other side, gravity, the patient inward pull of everything on everything, every galaxy tugging on every other, trying to slow the expansion down. And the fate of the universe seemed to hang on a simple question of arithmetic. If there was enough matter in the cosmos, gravity would win. The expansion would slow, stop, and reverse, and the universe would collapse. If there wasn't enough, expansion would win, and the universe would coast outward forever, thinning and cooling without end. Two possible endings decided by a single number, the weight of everything. Astronomers spent decades trying to measure that number. They counted galaxies, they weighed clusters, they added up all the matter they could find, visible and invisible. And slowly, an answer took shape. There did not seem to be nearly enough matter to halt the expansion. The universe, it appeared, would expand forever, slowing gradually, gently, but never stopping. That was the picture as the 20th century drew toward its close, a long, slow, ever calmer coast into eternity. And then, in 1998, the universe surprised us with one of the most shocking discoveries ever made. Two rival teams of astronomers were studying distant exploding stars, supernovae, using them as beacons to measure how the expansion of the universe had changed over billions of years. Everyone knew what they would find. They would find the expansion slowing down, dragged at by gravity, the only question being by how much. That was the entire purpose of the measurement. But that is not what they found. When the data came in, both teams, independently, found the same impossible thing. The expansion of the universe is not slowing down at all. It is speeding up. Something, some unknown influence woven into empty space itself, is pushing the galaxies apart faster and faster. Overwhelming gravity on the largest scales, pressing the cosmos outward with a strength that grows as the universe grows. We call it dark energy, and we must be honest, the name is a confession. We do not know what it is. We only know what it does and how much of it there is, and the amount is staggering. When you add up everything in the universe, all the stars and gas and dust, all the invisible dark matter holding the galaxies together, all of it together makes up less than a third of the total. The rest, roughly 70% of everything that exists, is dark energy. The dominant ingredient of reality is a mystery. And here is why that matters for tonight. The fate of the universe is no longer a tug of war between expansion and gravity. Gravity has already lost. The future belongs to dark energy, which means the ending of the universe. Which of those three deaths actually comes to pass depends entirely on the true nature of the one thing in the cosmos we understand least. If dark energy is constant, a fixed, unchanging property of space itself, the same in every era, then the universe expands forever, faster and faster, and the ending is the long, cold fading we call the Big Freeze. If dark energy grows stronger with time, feeding on the very expansion it creates, then the ending is far more violent. The runaway tearing we call the Big Rip. And if dark energy should ever weaken, fade, or reverse, if the push should ever become a pull, then the oldest ending of all comes back onto the table. The Great Collapse, the Big Crunch. Three endings, hanging on the behavior of one mysterious ingredient. So let's take them one at a time, slowly, gently, in the dark, beginning with the oldest idea of them all. The universe that falls back in. The Big Crunch is, in a way, the most intuitive ending ever proposed, because it is simply the beginning played in reverse. If the Big Bang was everything rushing apart, the Big Crunch is everything falling back together. Throw a ball into the air and gravity slows it, stops it, and pulls it home. For a long time, many physicists suspected the universe might work the same way, that the great outward rush of the Big Bang was the throw, and that gravity, given enough time, would be the catch. The expansion would slow across billions of years, hesitate, stand still for one impossibly balanced cosmic moment, and then, almost imperceptibly at first, begin to reverse. Imagine watching it happen. Not that anyone could, in any single lifetime, this would unfold over eons, but imagine time compressed, the whole story visible at once. The distant galaxies which have been growing fainter and more distant for all of cosmic history slow their retreat. They drift to a stop, and then, one by one, they turn around. The light of distant galaxies, stretched and reddened by the expansion for billions of years, begins to compress and turn blue instead. The sky, ever so slowly, starts to fall. Galaxies that spent eternity fleeing from one another now approach, gather, merge. The universe grows denser, era by era, and warmer, because all the light ever emitted by all the stars that ever shone is now being squeezed into a smaller and smaller volume, concentrated instead of diluted. That is one of the eeriest details of the Big Crunch. The end would not come as cold, but as heat. As the collapse accelerated, the background glow of the sky, That faint whisper of leftover warmth from the Big Bang, now just under 3 degrees above absolute zero, would rise gently at first, then not gently. There would come an era late in the collapse when the sky itself glowed as warm as a summer day everywhere, in every direction, and then as hot as an oven, and then hotter than the surface of a star. In the final ages, the temperature of space itself would climb so high that the stars would no longer be able to shed their heat into it. They would dissolve, boiled from the outside in by a sky brighter than their own surfaces. Galaxies would blur together into a single ocean of stars. Matter itself would come apart into the glowing plasma it began as. And at the last, everything, every particle of every world, every scattered atom of every long-dead star would be crushed together into a state of unimaginable density and heat, a mirror of the very moment the universe was born. The Big Bang run backward, arriving where it started, and there the equations fall silent, exactly as they do at the beginning of time. Whether that final crushed moment would be the true end of everything, a full stop after which there is simply nothing more, or whether it might rebound, a new Big Bang, a fresh universe bouncing out of the ashes of the old, the way some physicists have imagined, is a question we cannot answer. You might remember from another night on this channel that there are thinkers who believe endings like this are really beginnings in disguise. It's a beautiful thought, and it hovers over the big crunch like a small candle. But tonight we are staying with the endings themselves, and taken purely as an ending, the crunch is the most dramatic homecoming imaginable. A universe that returns at the last to the fire it came from. Now, is this actually going to happen? For decades, the Big Crunch was considered a live possibility, one of the two great candidate fates. Then came 1998 and the discovery of dark energy, and the crunch fell out of favor almost overnight. A universe whose expansion is accelerating is a universe running hard in the opposite direction of collapse. Gravity never gets its chance to catch the ball because something keeps throwing it harder. And so, for the past couple of decades, most cosmologists have filed the Big Crunch away as the least likely of the endings. A beautiful old idea overtaken by the data. But here is where I have to tell you something genuinely exciting, because in just the last few years, the story has taken a turn that almost nobody expected. A new instrument, the dark energy spectroscopic instrument, mapping millions upon millions of galaxies to trace the history of the expansion in exquisite detail, has produced hints, and I want to be careful with that word, hints, that dark energy may not be constant after all. The early results suggest tentatively that dark energy may have been very slightly weakening over cosmic time. The evidence is not conclusive. It may yet dissolve into nothing, as tentative signals in science often do. But if it holds, if dark energy really is fading, then everything about the far future reopens. A dark energy that can weaken is a dark energy that could conceivably one day fade to nothing or even reverse. And a universe like that could, in the deep future, stop expanding and fall back in. The big crunch, the ending everyone had quietly buried, has stirred in its grave. Right now, tonight, telescopes are gathering the data that will tell us whether the oldest ending of them all deserves a second look. We are living inside the very moment when the fate of the universe is being weighed. Let's turn now to the second ending, and I'll be honest with you, this is the violent one. This is the ending physicists gave the most unnerving name of all, the Big Rip. If the crunch is the universe falling home into fire, the rip is the universe being torn apart, structure by structure, from the largest things down to the smallest, until nothing, not a galaxy, not a star, not a single atom, remains whole. Here's the idea. We said the big freeze happens if dark energy stays constant, and the crunch becomes possible if it weakens. The big rip is what happens if dark energy does the opposite, if it grows stronger over time. Physicists have a name for this hypothetical, more aggressive form of the stuff. They call it phantom energy, and the name suits it. Ordinary dark energy pushes the galaxies apart, but leaves the galaxies themselves alone. The things bound together by gravity, like our Milky Way, our solar system, our own bodies, are held firmly enough that the gentle cosmic stretching simply doesn't apply within them. Space expands between the galaxies, not inside your house. That's why, in most futures, the expansion is a distant, harmless thing. But phantom energy would not stay harmless. If dark energy grows stronger as the universe expands, and the expansion feeds the dark energy, which drives faster expansion, which feeds it further, a runaway spiral, then the outward push eventually grows strong enough to start overpowering the forces that hold things together. Not all at once, in order. From the biggest, most loosely bound structures down to the smallest, most tightly bound ones. The universe would be dismantled in sequence like a great building being stripped floor by floor, and physicists have actually worked out the schedule. In one carefully studied version of this scenario, and I want to be clear that this is an illustration, a worked example rather than a prediction, the Big Rip arrives roughly 22 billion years from now, and the destruction follows a countdown that is almost unbearably precise. About 200 million years before the end, the great clusters of galaxies come apart. The expansion grows strong enough to overwhelm the gravity binding galaxy to galaxy, and the members of every cluster drift away from one another like a crowd dispersing after the show. Then, about 60 million years before the end, it reaches the galaxies themselves. Our Milky Way, that ancient wheel of 400 billion stars held together for 13 billion years by its own gravity, is peeled apart, its stars released one by one into the swelling dark, the great spiral dissolving like smoke. And then the countdown accelerates, and this is where it becomes truly strange. About 3 months before the end, the expansion grows strong enough to overwhelm the gravity of a single star system. Our solar system, or whatever quiet solar systems still exist in that far era, comes unbound. The planets are plucked away from their suns, released from orbits they had held for billions of years, and sent drifting alone into the dark. 3 months. After billions upon billions of years of stability, the last 3 months. In the final half hour or so, planets and stars themselves are pulled apart, the expansion now stronger than the very rock and plasma of worlds, stronger than the gravity of a star, everything shredding outward into streams of matter. And in the last fraction of the last second, an interval so brief it can barely be written down, 100 millionth of a trillionth of a second before the end, the expansion becomes stronger than the electric forces holding atoms together. The atoms themselves are torn open. Then the very fabric of space, stretching at a rate beyond all meaning, reaches a state the equations cannot follow. And that is the end. Not cold, not fire, just tearing. A universe ripped so completely that not even the pieces survive, because the pieces themselves are ripped all the way down. There is something almost vertiginous about the Big Rip, and I think it's the ordering of it, the way the destruction moves from the cosmic to the intimate. For almost all of that 22 billion years, nothing seems wrong at all. The catastrophe spends billions of years being invisible, then millions of years being distant, then months being local, then minutes being personal. If there were astronomers alive in that final era, they would watch the disaster approach through their instruments for millions of years, the clusters dissolving, the sky slowly emptying, knowing the whole time exactly what it meant, and exactly when it would arrive, and that nothing anywhere could stop it. So, should you be worried about the Big Rip? No, and I mean that quite firmly, for 2 reasons. The first is the time scale. Even in the versions of the theory where it happens at all, the end lies tens of billions of years away, several times the current age of the universe, an expanse of time in which the sun itself will have lived and died long before. And the second reason is better still. The evidence is against it. For phantom energy to be real, dark energy has to be growing stronger. And everything we have measured so far, including those tantalizing new results we just talked about, points the other way. If dark energy is changing at all, it appears to be weakening, not strengthening. The Big Rip requires the one behavior we have the least evidence for. It remains in the catalogue of possible endings because we cannot yet rule it out completely, but of the 3 great deaths, it is the least likely. The universe, as far as we can tell, is not going to be torn apart. Its true ending is quieter than that, far quieter. But before we come to the quiet one, the real one, there is one more ending we have to meet. The strange one. The one that doesn't wait. Everything we've discussed so far, the crunch, the rip, the freeze, still to come, unfolds over billions upon billions of years. They are endings you can see coming from across eternity. But there is one scenario in modern physics that works differently. One ending that, in principle, needs no warm-up, no countdown, no warning of any kind. Physicists call it vacuum decay, and before I describe it, let me promise you the ending of this section in advance. By the time we're done, you'll see why the physicists who study it sleep perfectly well at night. Hold on to that promise, because the idea itself is genuinely eerie. Here is the heart of it. Empty space, the vacuum, is not truly nothing. It has properties. It hums with invisible fields, the deep machinery underneath all of physics, and the particular settings of those fields determine everything. The masses of particles, the strengths of forces, the rules of chemistry, the very possibility of atoms. And physics asks a strange question about those settings. Are they final? Is our vacuum, the version of empty space we live in, the most stable version there could be? Or is it merely resting, like a ball sitting in a small hollow partway down a hillside, stable for now, but with a deeper valley somewhere below it? When physicists measured the properties of the Higgs field, one of those deep fields, the one that gives particles their mass, the numbers came back unsettling. Taken at face value, they suggest that our vacuum may not be the deepest valley. That empty space, everywhere, may be what's called metastable, genuinely stable for immense stretches of time, but not forever, not in principle. And if that's true, then there is a possibility, however remote, that somewhere, someday, through the strange dice rolls of quantum physics, a tiny region of space could slip from our valley into the deeper one. A bubble of new vacuum, a bubble of space with different rules, would be born, and that bubble would grow. It would expand outward in all directions at essentially the speed of light, converting everything it touched into the new vacuum. Inside the bubble, the constants of nature would be different. Atoms as we know them could not exist. Chemistry could not exist. Nothing built in our universe could survive the crossing. Stars, worlds, everything the bubble swept over would simply cease to be what it was, instantly remade into whatever the new physics allows, which may be nothing at all. And because the wall of the bubble advances at the speed of light, no signal, no telescope, no possible observation could ever warn you it was coming. The light announcing its arrival arrives with the thing itself. If a vacuum decay bubble were racing toward Earth right now from somewhere across the galaxy, tonight would look exactly like every other night. The sky would be calm. The stars would shine. And that is precisely why some people find this scenario so uniquely unsettling. It is the one ending with no countdown at all. So now let me keep my promise, because there are 3 very good reasons this idea should not cost you a moment of sleep. First, the timescales. When physicists calculate how long a metastable vacuum like ours would be expected to last before any bubble forms anywhere, the answers are not millions of years or billions or trillions. They are numbers so large they make the entire story of the universe so far look like nothing. Spans written as a 1 followed by hundreds of zeros. The universe would be expected to fade, cool, and die its slow, natural death countless times over before a single bubble ever formed. Second, The calculation itself stands on the very edge of what we know. It assumes our current theories hold perfectly all the way up to energies we have never probed. And if there is any new physics up there, any undiscovered piece of the puzzle, the entire conclusion can change, and our vacuum may be perfectly, permanently stable after all. Many physicists suspect exactly that. And third, and this is the loveliest one, the universe itself protects us. Because space is expanding and the expansion is accelerating, distant regions of the cosmos are receding from us faster than light can cross the gap. Even if a bubble formed somewhere out there in the deep universe, it could never reach us. The expansion would carry us away from it faster than it could chase. In an accelerating universe, even the speed of light has a leash. Almost the entire cosmos is, and will forever remain, permanently out of range. So vacuum decay stays where it belongs, not as a fear, but as a thought, one of the strangest and most humbling thoughts physics has ever produced. The idea that the laws of nature themselves might be provisional, that even empty space might have an expiry date written somewhere in numbers too large to matter. Let it be what it is, a shiver of cosmic vertigo followed by the deep calm of realizing the numbers are on our side overwhelmingly, absurdly, forever. And now, with the dramatic endings behind us, the collapse, the tearing, the bubble, we come at last to the ending that the evidence actually favors, the real one, as best we can tell, the long, slow, quiet one, the big freeze. And I want to walk through it properly, not as a headline, but as a journey, because the true end of the universe is not an event. It is a landscape, the largest landscape there is. Here is the big freeze in a single sentence. If dark energy stays roughly as it is, the universe simply keeps expanding forever, and everything within it slowly runs down. The stars burn out, the matter decays, the black holes evaporate, and the cosmos settles over a span of time that beggars every comparison into a cold, dark, silent, almost perfectly empty eternity. No collapse, no tearing, no final bang of any kind. The universe does not end the way a story ends. It ends the way an ember ends, by cooling gradually, imperceptibly, into the dark. Physicists call it the heat death, and the name means the death of usable heat, a universe where the temperature everywhere has evened out so completely that nothing can ever happen again. But a summary like that hides the strangeness and the beauty of the actual journey. So let's take it era by era, starting close to home, in a future near enough to almost touch. The first ending on the road to the end of everything is a local one, the death of our own star. The sun is about halfway through its life. In roughly 5 billion years, it will exhaust the hydrogen fuel in its core and begin to die, swelling into a red giant so vast it will swallow Mercury and Venus and fill half the Earth's sky, before gently shedding its outer layers into space and collapsing into a white dwarf, a hot, dense ember about the size of the Earth, destined to spend the rest of eternity slowly cooling. Around the same era, and if you've been with this channel a while, you know this story, our galaxy itself has an appointment. The Milky Way and Andromeda will merge, their stars mingling into a single, vast, elliptical galaxy. A new home built from two old ones. 5 billion years from now, the universe will still be young, still bright, still busy making stars. The death of the sun is not the end of anything except us. It is simply the first bell ringing far down the line, reminding us that nothing, not even the steady star that raised us, is permanent. And you don't have to look 5 billion years out to find the great winding down at work. It is happening here, tonight, in the sky outside your window, so gently that it took us most of history to notice. The moon is leaving us. Every year, it drifts about 4 centimeters farther from the Earth, roughly the pace your fingernails grow, spiraling slowly outward as it has for billions of years. And as it recedes, it takes something with it, the Earth's own spin. The tides the moon raises act as a gentle brake on our turning world, and so the days are lengthening, imperceptibly, a fraction of a second per century, but relentlessly. When the moon formed, an Earth day lasted perhaps 5 or 6 hours. The leisurely 24 hours you live today is the slowed-down product of eons of lunar braking, and the slowing continues still. Left alone long enough, the two worlds would settle into a final embrace. The Earth's day stretched until it matches the moon's orbit, the two locked face to face forever. The same side of Earth gazing at the same side of the moon for eternity. As it happens, the sun will intervene long before that consummation arrives. But I love what this small local story tells us. The same patient physics that will one day quiet the whole universe is already at work in the most familiar object in our sky. The moon drifting outward, the days growing longer. These are the heat death in miniature, running on your bedroom clock. The universe does not wind down somewhere else someday. It winds down everywhere, always, at exactly this gentle, survivable, almost loving pace. Now, let the ages roll forward and watch what the accelerating expansion does to the sky. This, to me, is one of the most haunting chapters of the whole story, because it is not about destruction at all. It is about disappearance. As dark energy drives the galaxies apart faster and faster, the most distant ones cross a terrible threshold. The space between us and them begins stretching faster than their light can cross it. Their light simply stops arriving. One by one, from the farthest out inward, the galaxies slip over the horizon of the visible, not destroyed, just carried out of reach forever, their final light fading and reddening like the last note of a song. Give it 100 billion years or so, and everything beyond our own merged galaxy and its closest gravitationally bound companions will be gone from the sky. Every other galaxy in the universe, the hundreds of billions we can photograph tonight will have vanished beyond a horizon no telescope can pierce. And here is the part of that thought I find genuinely moving. Imagine astronomers born in that far era, creatures of a world circling some long-lived star 100 billion years from now. They would look up and see their own galaxy, an island of stars floating in a blackness that is otherwise perfectly, absolutely empty. No other galaxies, no cosmic microwave background. That faint afterglow of the Big Bang will have been stretched into undetectability long before. No expansion to measure, because there will be nothing visible whose motion could reveal it. All the evidence, every clue that led us to the Big Bang, to dark energy, to the story we've told tonight, will have left the sky. They would conclude, reasonably, using perfect logic on the evidence available, that the universe is one static island of stars in an infinite void, eternal and unchanging. They would be wrong, and they would have no way, even in principle, of discovering it. The universe's own history will have become unknowable to its inhabitants, which means that we, you, tonight, lying in the dark, are living in a privileged window. We happen to exist in the brief cosmic era when the evidence is still in the sky. The universe is telling its life story right now, and we are among the only generations across all of time in the audience to hear it. The ages roll on, and the next great chapter is the one that gives the frieze its melancholy heart. The end of the stars. Stars are born from clouds of gas, and the universe's supply of fresh gas is finite. Every star that forms locks some of it away. Every generation leaves less for the next. Star formation has, in fact, already peaked. It happened billions of years before the Earth existed, and the universe has been slowly winding down its stellar birth rate ever since. We live in the long afternoon, not the morning. Eventually, the estimates land somewhere around 100 trillion years from now, roughly 10,000 times the current age of the universe. The last star will be born. Think about that being for a moment. Somewhere in the deep future, there will be an actual last star. The final one. At the end of a chain of hundreds of billions of trillions, the last time in all eternity that a cloud of gas collapses and ignites, and a new light comes on in the universe, and after it, the long dimming. The big, bright stars die fast. In millions or a few billions of years, the sun-like stars fade over 10 billion or so, but the smallest stars, the red dwarfs, dim, frugal, patient, burn their fuel so slowly that they can last for trillions of years. As the ages pass, the universe's light reddens and dims, the brilliant blues and whites dying out first, until the only living stars left are these small red embers scattered thinly through galaxies grown dark. And then, one by one, across spans of time we have no words for, even they gutter out. There is a last one of those too, somewhere, a final flicker, the last natural starlight the universe will ever make. And then the stelliferous era, the age of stars, the only era we have ever known, the era in which every myth and every memory and every living thing has existed, is over. It will have lasted about 100 trillion years. And it is, by the clock of the universe's whole future, barely the first instant. What remains after the last star dies? Corpses. But corpses of remarkable variety, and the era that follows, the degenerate era, is stranger and more interesting than mere darkness. The galaxies of that age are graveyards, but well-stocked ones, white dwarfs by the hundreds of billions, the cooling cores of dead sun-like stars, each one slowly dimming from white heat toward darkness across trillions of years until they become what physicists call black dwarfs, cold, dark spheres of crystallized matter, the ultimate ash of starlight. There are neutron stars, the collapsed hearts of giants still spinning, still faintly warm, with the memory of their violent births. There are black holes, patient as ever, and there are the failed stars, the brown dwarfs, balls of gas that never quite grew massive enough to ignite, drifting in their uncountable numbers through the dark. And here is something about those cooling white dwarfs that sounds like a fairy tale and is simply true. As they cool, they crystallize. A white dwarf is mostly carbon and oxygen, compressed to fantastic density, and as the long ages drain its heat away, its interior begins to freeze, not into ice, but into a vast crystal lattice, the atoms locking into place like frost spreading across a window from the core outward. Astronomers have watched this happening. Surveys of nearby white dwarfs have caught thousands of them in mid-crystallization, and one famous dead star some 50 light-years away has been measured to be substantially crystal already. A sphere of crystallized carbon thousands of kilometers across, which is to say, in the loosest poetic sense, something very like a colossal diamond hanging in space. This is what dead suns do with eternity. They become jewels, and this will be the sun's own fate. The star warming your face on a summer afternoon will, in the deep future, be a cold, dark, crystalline sphere. The entire brilliant history of our solar system compressed into a silent gem, drifting through the age of remnants. If the universe's endings were designed to be mourned, someone forgot to tell the white dwarfs. They spend their afterlife crystallizing into the most beautiful objects ever made. And every so often in that endless night, something wonderful happens. Two of those brown dwarfs, wandering blindly, collide, and their merged mass crosses the threshold that neither could reach alone. A star ignites. A single new light comes on in a galaxy that has been dark for eons, one true star burning alone amid trillions of corpses, perhaps the only light for millions of light years in any direction. The mathematics suggests such accidents will keep happening, rarely, for a very long time. A universe not entirely dark, but lit by one lonely lamp at a time, flickering on for a few trillion years, then fading Then, somewhere else, ages later, another. I find that image almost unbearably tender. The universe, long after the age of stars, still occasionally striking a match. Even the galaxies themselves do not survive the degenerate era, and the way they end is stranger than you'd guess. They don't collapse, and they don't disperse all at once. They evaporate. Over spans of time around 10 million trillion years, 100 million times longer than the universe has existed, the dead stars of a galaxy, endlessly swinging past one another in their orbits, play out a slow, gravitational lottery. Every close encounter between two remnants shuffles their energies. One gets flung a little faster, the other settles a little deeper. And given enough eons, the arithmetic is merciless. Again and again, one partner in the exchange gains enough speed to escape the galaxy entirely, flicked out into the intergalactic dark like a spark off a grindstone. One by one across that unimaginable stretch, the galaxy sheds its stars into the void. The corpses that aren't ejected drift inward instead, surrendering their orbits, sinking by the same slow bookkeeping toward the great black hole at the center, which swallows what the dark is not given. In the end, a galaxy of hundreds of billions of stars resolves into just two inheritances, a scattered diaspora of frozen remnants, each one utterly alone, sailing through intergalactic space forever, and one grown, patient black hole holding what remains. The great cities of stars dissolve the way all cities eventually do, not by catastrophe, but by everyone, gradually moving away. But even the corpses are not forever, and here the story reaches one of its deepest uncertainties. Ordinary matter itself may not be permanent. The protons at the heart of every atom, the bedrock particles of everything solid, everything real, may, according to some of our theories, very slowly decay, dissolving over immense timescales into lighter particles and faint radiation. I want to be honest, proton decay has never been observed. Experiments have watched enormous tanks of matter for decades without catching a single proton in the act, which tells us that if it happens at all, the time scale is beyond 10 million trillion years. But if it does happen, and many physicists suspect something like it must, eventually, then, in the truly deep future, the black dwarfs and dead worlds and drifting dust of the degenerate era will not merely go cold. They will evaporate atom by atom from within. The last planets will not shatter. They will fade, growing lighter and more tenuous across eons, until the final proton of the final rock gives up its substance in a whisper of energy, and ordinary matter, the stuff of stars and worlds and hands and faces, is simply gone from the universe, and then only the giants remain. The black hole era, an expanse of time so vast that everything we've described so far, the whole 100 trillion years of stars, the immensely longer age of the corpses, rounds to zero beside it. The universe becomes a darkness populated only by black holes, the stellar ones and the supermassive monsters that once anchored galaxies, some grown to billions of suns from their long feasting, now with nothing left to feast on. They drift through the expanding dark, the last great objects in existence, the final keepers of all that mass. And, as we've explored before, and as Stephen Hawking taught the world, even they are mortal. Black holes leak. Slowly, through quantum whispers at their horizons, they radiate their mass away, shrinking over timescales that require a 1 followed by 67 zeros for the small ones, a 1 followed by as many as 100 zeros for the giants. Somewhere at the bottom of that number, the last black hole in the universe, the final object, the last thing, shrinks to nothing and vanishes in a final soft flash of radiation. The universe's very last event in any meaningful sense. After it, nothing but the faintest imaginable haze of stray particles and stretched light, thinning forever into an expansion that never ends. That is the dark era, the final chapter and the longest, indeed, the eternal one. A universe at almost exactly absolute zero, almost exactly empty, where the distances between the few remaining particles grow beyond all naming, and where nothing changes and nothing happens and nothing ever will again. Maximum entropy, perfect equilibrium. The heat, death. Not an explosion, not a collapse, not a tearing, just the universe having spent every last coin of its energy, resting in a stillness that has no end. If you were somehow there, you couldn't be. Nothing can be, that's the point. You would find no marker of everything that came before. No monument, no ruin, no ash. The stars, the galaxies, the worlds, the whole blazing carnival of cosmic history, all of it smoothed into a silence so complete that even the words before and after lose their grip. I know how that sounds. Spoken quickly, it may be the bleakest paragraph in all of science, but stay with me, because now that we've walked all the way to the end, we've earned the right to turn around and ask what it actually means. And this is where the whole journey, I promise, becomes something else. Let's start with a question we've been stepping around all night. Why must the universe end at all? Why can't it simply keep going, stars dying and new ones forming, matter recycling, the great carnival running forever? The answer is one of the deepest laws in all of physics. And the remarkable thing is that we didn't discover it by studying the stars. We discovered it by studying steam engines. In the middle of the 19th century, engineers trying to squeeze more work out of coal and boilers uncovered a rule that would not bend. Energy, left to itself, always flows from concentrated to spread out, from hot to cold, from useful to useless. You can burn a lump of coal and get work out of it exactly once. After that, its energy still exists, but it has dissolved into gentle, even warmth that can never be gathered up and used again. This is the second law of thermodynamics, the one-way street at the heart of nature, and it took only a few years for the physicists of that era to follow the thought to its staggering conclusion. If energy always runs downhill, if every fire, every star, every process in existence spends concentration and can never fully win it back, then the universe itself is like a clock that was wound once at the beginning and is slowly, irreversibly winding down. The stars are not eternal fixtures. They are bonfires burning through a finite inheritance, and a universe of bonfires must eventually become a universe of ash. It's worth pausing on how shocking this was. In the 1850s, decades before anyone knew what stars were made of, a lifetime before anyone knew other galaxies existed, Victorian physicists, men in waistcoats working with pistons and temperature tables, correctly deduced the ultimate fate of the cosmos. They called it the heat death even then, and the idea landed on that century like a stone. Philosophers agonized over it. Writers wove it into their nightmares. It seemed to many like the cruelest discovery science had ever made. The news that the universe itself was mortal, that everything in the deepest possible sense was temporary. Every ending we've explored tonight, all the modern cosmology, the dark energy, the eras and the numbers, all of it is, in a sense, just the detailed working out of that one Victorian insight. The clock was wound once, and it is running down. But here's a gentler way to hold the very same law. The second law of thermodynamics, the rule that dooms the universe, is also the reason anything happens at all. Energy flowing downhill is what powers every single event in existence. It's why the sun shines, concentrated nuclear fuel dissolving into scattered light. It's why rivers run, why storms turn, why engines fire. It's why you are alive. Every heartbeat, every thought you have ever had is powered by energy flowing from more concentrated to less through the exquisite machinery of your body on its long way down. A universe that could never run down would be a universe where nothing could ever run at all, frozen not in cold, but in perfect, changeless balance, with no flow, no events, no time worth the name. The mortality of the universe and the aliveness of the universe are the same fact, seen from two sides. The cosmos burns bright precisely because it is burning through something. The price of a universe where things happen is a universe that ends. Now let's take the measure of the road itself, because I've been throwing around numbers like 100 trillion years, and numbers like that slide off the mind unless you slow down and hold them. So try this. Compress the entire age of stars, from the first star that ever ignited to the last red dwarf that will ever fade, that whole 100 trillion year era of light into a single year. One calendar year from midnight on the 1st of January to midnight on the 31st of December, containing the entire luminous lifetime of the universe. On that calendar, where are we now? all of cosmic history so far, the Big Bang, the first stars, the birth of every galaxy, the formation of the Earth, the age of the dinosaurs, the whole of human civilization. Tonight, all of it fits inside the first 70 minutes of New Year's Day. It is the first hour of the first morning. Outside, the sky is still dark. The year of stars stretches ahead, spring, summer, autumn, the long fade of December. And virtually none of it has happened yet. When we say the universe is going to die, this is what we're actually saying: that the party will end sometime next winter, and we are saying it at 1 in the morning on January the 1st. And even that comparison undersells it, because the year of stars is only the opening moment of the universe's full story. If you tried to extend the same calendar to cover the black hole era, those 10 to the 100 years, the numbers break every analogy you can build. There are not enough seconds in 1 trillion years, not enough grains of sand on every beach of every world, not enough atoms in the visible universe to serve as counters for that span. The deep future is not merely longer than the past. It is longer than the past in a way that makes the past, all 14 billion years of it, mathematically indistinguishable from the first instant. We are not living near the end of the universe. We are living at its very beginning, the brief, bright, crowded dawn, when the cosmos is still young enough to remember being born. Here's a question the far future raises that I find impossible to stop thinking about. Could anything be alive out there in those late eras? Not us. No creature of warm blood and liquid water survives the death of the stars, but life in the widest sense, minds, awareness, something that thinks. Could consciousness, in any form, outlast the light? Physicists have genuinely studied this, and the classic analysis came from Freeman Dyson, one of the great imaginative minds of the 20th century. His insight was that thought, in any conceivable kind of mind, is physics. Thinking processes energy and produces waste heat, which means thinking, like everything else, must obey the second law. A mind in the far future, in a universe grown cold and dim, would find energy fantastically scarce. But Dyson noticed something lovely. The colder the universe gets, the cheaper thinking becomes. A cold, slow mind, some vast, diffuse intelligence built from the thin resources of the degenerate era, could run on almost nothing if it were patient enough. And patience, out there, is the one resource in infinite supply. Dyson imagined minds that slow themselves in step with the cooling cosmos, thinking a single thought across 1,000,000 years, then hibernating for 1,000,000,000, waking to think again. From inside, such a mind would notice nothing strange. Its clock and its consciousness would slow together, and subjective time would flow on. And under certain assumptions, Dyson's mathematics found something astonishing. By slowing forever, such minds could stretch a finite reserve of energy across an infinite subjective future. Thought, in principle, might never have to end. An eternity of experience, sipped from a cooling universe through an ever slower straw. Now, honesty requires the update. Dyson did this work before we knew about dark energy, and an accelerating universe is crueler to the scheme than the one he assumed. The horizon closes in, the resources thin faster, and most physicists now doubt the trick can be sustained literally forever. But even so, the window it leaves open is immense, almost beyond meaning. Minds could, in principle, persist for spans that make the age of stars look like a spark, slow, cold, vast intelligences drifting through the twilight eras, remembering, perhaps, the brief early age when the universe blazed with hot, fast little creatures like us. When we say the universe becomes uninhabitable after the stars, we are speaking of our kind of habitation. The deep future may yet have its citizens, and there is something quietly wonderful in that thought, that awareness. The universe's strange ability to know itself might not be a brief flare at the beginning, but a long, dimming candle carried almost all the way to the door. And what about everything that will be lost? This, I think, is the real weight people feel when they hear about the heat death. Not fear exactly, but a kind of anticipatory grief. If everything ends, if the last black hole evaporates and the darkness closes over it all, then was any of it real? Does anything we do matter if no trace of it survives? I want to offer you two answers, one from physics and one from somewhere deeper. And I'll give you the physics one first because almost nobody knows it, and it is beautiful. Nothing that happens is ever locally erased. Here is what I mean. Every event in your life, every word you've spoken, every kindness, every ordinary Tuesday happened at a particular place and moment in space-time. And from that moment, its influence spreads outward at the speed of light, like a ripple that never stops widening. The light that left the Earth on the day you were born is now a sphere some decades of light years across, still traveling, still carrying, in principle, however faintly, the imprint of that day. Nothing ever catches up to it and cancels it. In the geometry of the universe, the past is not deleted as time moves on. It is woven permanently into the structure of what has happened, the fixed and unchangeable backstory of every future moment. The heat death does not reach backward. It cannot unmake a single afternoon of your life. When the universe is dark and silent, it will still be true that stars once shone here, that worlds turned, that on one small blue planet, for a little while, there was music. The far future is empty of events, but it is not empty of history. It will be, forever, the far future of this, of everything that ever happened, including you. An ending, even the ending of everything, has no power over the fact that things were. And the deeper answer is simpler still, and you already know it, because you live it every day. Nothing in your life is precious because it lasts forever. Nothing ever has been. A piece of music does not need to play eternally to be beautiful. In fact, it must end to be music at all. An endless note is just noise. A perfect summer evening matters more, not less, because it becomes night. You have never once demanded permanence from the things you love, from a meal, a laugh, a conversation, a sunset, and their impermanence has never made them meaningless. It has made them precious. The universe is the same, only larger. It is not a monument built to stand forever. It is a performance. And the fact that the performance ends is not the tragedy of the story. It is what makes it a story. Since the whole fate of the cosmos turns on dark energy, it's worth sitting for a moment with the question of what this strange ingredient might actually be, because the honest answer is one of the great open wounds in physics, and it's fascinating even in its unfinished state. The leading idea is that dark energy is simply a property of space itself, that every cubic meter of emptiness carries a tiny, fixed amount of energy woven into the vacuum, the same everywhere and always. Einstein himself wrote a term like this into his equations more than a century ago. He called it the cosmological constant, and then famously abandoned it, reportedly calling it his greatest blunder. If dark energy is Einstein's constant, then its strength never changes. The expansion accelerates forever, and the big freeze is our destiny, full stop. That is the simplest reading of the evidence, and simplicity counts for a lot in physics. But there's a problem, and it's a spectacular one. When physicists try to calculate from quantum theory how much energy empty space should contain, the answer comes out wrong. Not wrong by a little, but wrong by a factor so enormous it has been called the worst prediction in the history of science. Roughly A1, followed by 120 zeros too large. Something about our understanding of the vacuum is deeply, embarrassingly incomplete. And that embarrassment is exactly why the other possibilities stay alive. Perhaps dark energy is not a constant at all, but a field, a dynamic, evolving thing like an invisible fluid filling the universe with a strength that drifts over cosmic time. Physicists call this idea quintessence, borrowing the old word for the fifth element, the substance of the heavens. A quintessence that weakens opens the road back toward the crunch, one that strengthens opens the road to the rip. The entire question of how the universe ends turns out to be the same question as what empty space is, the largest of all mysteries hiding inside the smallest of all things, the humble vacuum. And here's what I find genuinely thrilling. We may actually get the answer, not in some distant sci-fi future, in the coming years and decades. Right now, this very night, instruments are working on the problem. That spectroscopic survey we mentioned is measuring the positions of tens of millions of galaxies, reconstructing the expansion history of the universe, epoch by epoch, like reading tree rings. A space telescope called Euclid is mapping the shapes of billions of galaxies to trace how dark energy has sculpted the growth of cosmic structure. More missions are coming, each sharpening the measurement of one number, the number that says whether dark energy is constant or changing, and if changing, which way. It is entirely possible that people alive today will live to see the fate of the universe settled, freeze, crunch, or rip, decided by data. Think about what a strange privilege that is. Of all the humans who have ever lived, all the generations who looked up and wondered, we may be the ones who find out how the story ends. Not by prophecy, by measurement. Before we turn toward the close, let me show you a few of the stranger wonders waiting in the deep future, because the far eras of the universe are not just dark, they are exotic in ways that stretch the imagination to its absolute limit. Consider what happens to matter itself if protons turn out to be stable and nothing decays. Even then, matter does not simply sit still forever. Over timescales that make the black hole era look brief, spans written as a 1 followed by 1,500 zeros, quantum physics allows solid matter to very slowly rearrange itself. Atoms locked in a cold black dwarf can, through quantum tunneling, fuse and shift, one improbable event at a time, and across those absurd stretches of time the improbable becomes inevitable. Every lump of cold matter in the universe would slowly transmute toward the most stable element there is, iron. The corpses of the stars would become iron stars, perfect, cold, dark spheres of iron, the most patient objects ever conceived, matter's final resting shape. Nothing in the universe would ever have built them. Time alone would have. Or consider the strange chemistry of the dark era. In that almost empty eternity, among the last particles drifting through the expansion, an electron and its antimatter twin, a positron, can occasionally find one another across the void and fall into orbit, forming a ghostly hydrogen-like atom called positronium. But in the vastness of that era, the orbits would be unlike anything we know, atoms larger than today's entire observable universe, a single bound pair of particles circling each other across a span wider than all the galaxies that ever existed, completing one orbit over spans of time, beyond all speech. The last structures in the universe, atoms the size of everything, spinning slowly in the dark, waiting out eternity before they, too, finally spiral together and annihilate in one last, small flash of light. If the universe's final age has a native art form, it is this: matter and antimatter, dancing the slowest waltz that will ever be danced. And notice something about all of these late wonders. The lonely brown dwarf stars flickering on, the iron spheres, the galaxy-sized atoms, none of them will ever be seen. There will be no eyes. They will happen, if they happen, in perfect solitude, wonders without witnesses, the universe continuing to invent astonishing things long after anyone is left to be astonished. I don't find that sad, exactly. I find it strangely reassuring, evidence that the universe's creativity is not a performance for us, but simply what it is, all the way down and all the way out, to the very end. The cosmos was busy being marvelous for 9 billion years before we arrived. It will go on being marvelous in its cold, slow way long after. We were never the point, We were something better. We were, for a while, the audience. Now, is the ending truly final? We've been speaking all night as though the heat, death, is the last line on the last page, and by everything we can measure, it may be. But I would be leaving out something important and something rather beautiful if I didn't tell you that a number of serious physicists suspect the story may not simply stop. The deep future hides loopholes, and it's worth meeting them, honestly labeled as speculation, before we close. The first loophole is the sheer, unimaginable length of eternity itself. The dark era is not merely long, it is endless. And in an endless stretch of time, quantum physics keeps rolling its dice forever. Events of vanishing improbability, things that would essentially never happen in any finite span, become, given literal eternity, guaranteed. The vacuum can fluctuate. Given enough time, numbers beyond all the numbers we've used tonight, those fluctuations could, in principle, conjure structure out of the emptiness. A particle here, an atom there, and at the far end of absurdity, perhaps something more. Some physicists have even speculated that a fluctuation or a quantum tunneling event in the fabric of space itself could seed an entirely new expanding universe, a fresh Big Bang, budding off from the cold ruins of the old one, the whole story beginning again from a whisper in the dark. Nobody knows if the mathematics of that truly works. But in a universe with infinite time on its hands, never becomes a very hard word to defend. And the second loophole you already know because we spent a whole night inside it once. Roger Penrose, the Nobel laureate whose strange and lovely idea we explored in another episode, believes the heat, death is not an ending at all, but a doorway. That a universe emptied of everything but light forgets its own size, and that this vast, cold nothing is, mathematically, indistinguishable from the hot, dense birth of a new cosmos. In his picture, the dark era we've walked through tonight is simultaneously the first instant of the next universe, the end and the beginning being the same moment, read in two directions. Most cosmologists remain unconvinced, as we said then, and honesty keeps it filed under speculation. But notice what all these loopholes have in common. Every one of them takes the bleakest fact in science, the final, perfect silence, and finds, hiding inside it, the possibility of a morning. Physics cannot yet promise that the ending is an ending, and there is something fitting, I think, in leaving it there. The universe keeps its last secret, and the last page of the book is written in ink we cannot quite read. Somewhere much nearer in the story there is a smaller ending that belongs to us, and it's worth placing on the map before we finish, because it changes how the big ending feels. Long, long before the universe grows cold, before the last star, before even a fraction of the age of stars has passed, the sun will die, and the earth with it. 5 billion years. That, not the heat death, is the ending that actually belongs to our world. And yet even that is no ending for life necessarily. 5 billion years is 1,000 times longer than there has been anything resembling a human on this planet. It is time enough for descendants we cannot imagine, or minds we build, to step outward, to other worlds, other stars, perhaps out among those 100 billion galaxies, while they still shine. The universe's death is so remote that it isn't really our problem at all. It is the inheritance of whatever we become. And if anything of us is still present to face the fading of the stars, it will be something that has already survived 100 trillion years, something that will have long since earned the right to face it. Our own chapter ends unimaginably earlier, in the bright morning of the cosmos, with the stars still thick in the sky. Whatever else is true of the far future, this is true of us. We will never see the universe as anything but young. And here is one last gift of the physics, the one I most want you to carry into sleep. Think about who is present at the end of the universe. No one. That is the entire point of the heat death. It is what a universe looks like when nothing can happen anymore, and nothing can happen includes suffering, includes fear, includes loss. Every creature that ever lives in the whole history of the cosmos lives in the eras of light and energy, the eras when the universe can support hearts and minds at all. The dark eras have no witnesses by definition. The cold arrives only after the last possibility of anyone being cold has passed. The universe does not die the way we fear dying, aware, resisting, grieving. It dies the way you fall asleep, gradually, painlessly, with no one present at the very last moment, because the falling asleep is precisely the fading of presence itself. Of all the endings physics could have written for the cosmos, the one the evidence favors is the gentlest one imaginable. The universe dies in its sleep. Let's make this personal for a moment, gently, because there's a version of tonight's whole story that is written in your own body. The atoms you are made of are old. Almost every one of them, apart from the primordial hydrogen, was forged in a star that died before the sun was born. You are, as the saying goes, stardust. But the saying only ever looks backward. Look forward instead. Those same atoms, the carbon in your skin, the iron in your blood, the calcium in your bones, do not end when you do. They return to the earth and cycle through it for as long as the earth lasts. When the sun swells and dies, 5 billion years from now, some of them will be swept up in whatever becomes of our world, perhaps scattered back into the galaxy, perhaps drawn into new clouds of gas, perhaps, it is genuinely possible, forged into new worlds around new stars the way their previous stars' ashes were forged into you. The atoms of your hands could be part of an ocean that hasn't formed yet, warming under a star that hasn't been born. And their journey goes on from there, through the age of stars into the long dark, riding out the eras we've walked tonight. Matter is the great traveler. You are a brief meeting place of very old travelers resting here for a lifetime before continuing on separately into the deep future, carrying, in the purely physical sense, a little of tonight with them all the way to the end. It's also worth remembering how recently and how humanly all of this knowledge arrived. The discovery that broke the old picture, the 1998 acceleration, has all the texture of a great story. Two rival teams racing each other across years, each secretly convinced the other would beat them to the answer. Months of checking and rechecking, because the result was so absurd that both teams assumed they had made a mistake. One team leader described feeling something close to dread, because announcing an accelerating universe meant telling the world's physicists that the dominant ingredient of reality had been missed entirely. Then the meetings where the two rivals compared notes and found, to their astonishment, the same impossible answer. The discovery held. It rewrote the fate of the universe, retired the crunch, crowned the freeze, invented the rip as a question. And in 2011, it won the Nobel Prize. And all of it happened within living memory. The fate of the cosmos, as taught tonight, is younger than the internet, which should tell you something about how the story may yet change. The people mapping the sky right now, chasing those hints that dark energy is drifting, are living the sequel to that story. And some of them, surely, lie awake, wondering if they're about to rewrite the ending again. Since we've leaned on it all night, let's take one slow moment to feel what the universe is expanding actually means, because it is stranger and lovelier than the words suggest. The galaxies are not flying apart through space like debris from an explosion. Space itself is stretching. New distance is, in a real sense, coming into existence between things. The classic picture is a loaf of raisin bread rising in an oven. The raisins don't crawl through the dough. The dough itself swells, and every raisin sees every other raisin recede, with the distant ones receding fastest. That's our sky. And this is also why, as we said, the expansion doesn't stretch you or the Earth or the galaxy. Wherever gravity or chemistry binds things tightly together, the binding simply holds, and the gentle swelling of space is overruled locally. The raisins don't expand, only the space between them does. The universe is not tearing anything apart tonight. It is only softly and everywhere at once, making more room. There is something almost hospitable in that image, a cosmos endlessly opening space, like a house adding rooms forever. The tragedy of the far future, if it is one, is only that the house eventually grows so vast that the guests can no longer find each other. And notice, finally, what the one-way flow of time gives us, even as it carries everything toward the ending. The same law that dooms the universe is the reason you have a past at all. The reason memory exists, the reason causes come before effects, the reason this evening follows this morning and can be looked back upon. In a universe without the second law, without the great downhill flow, there would be no difference between remembering and expecting, no direction to any story, no stories at all. Time's arrow is entropy's gift. The river only flows because it is flowing somewhere. Yes, ultimately, toward the sea, toward the great flat stillness at the end. But a river that didn't flow toward the sea wouldn't be a river. It would be a lake, still, closed, going nowhere, with nothing ever carried, nothing ever changed, nothing ever lived. We are creatures of the river. The price of the current that carries us is that it is indeed going somewhere, and tonight, at least, the sea is unimaginably far away. Before we gather everything together, let me take you on one last, quiet tour, a tour of the night sky itself, as it will appear in each of the great eras to come. Because the sky is how the universe tells its story to anyone living inside it, and the story it tells is going to change. Tonight, you know the sky, a few thousand stars, the soft band of the Milky Way, and, through telescopes, that ocean of galaxies beyond, going on and on to the edge of sight. 5 billion years from now, the sky belongs to the Great Collision. Andromeda arriving, the two spirals swinging through one another, night skies smeared with rivers of new stars and glowing gas. The most dramatic sky our corner of the universe will ever wear. 100 billion years from now, the merged galaxy hangs alone. A single colossal swarm of aging red-gold suns, and beyond it, nothing. The most perfect blackness in every direction, forever. The loneliest sky, though its inhabitants will never know anything was lost. 100 trillion years from now, the sky is nearly starless, a scattering of faint red embers against the black. The last dwarfs guttering, a sky like the final coals of a fire that has burned all night. And after that, the sky is a concept without a witness, pure darkness over darkness, interrupted once in a great while by the impossibly rare flare of some late accident, two dead stars colliding, one last unscheduled light. Each of those skies is the same universe. Each would seem, to anyone under it, like the only universe there had ever been. The sky you will see tonight or tomorrow night, cluttered, brilliant, crowded with galaxies, is simply the first page of that long album. It is worth going outside sometimes and looking up and knowing which page you're on. And it's fair to ask, many people do when they first hear all this, can't anything be done? If minds persist into the far future, minds of unimaginable capability, with millions of millennia to prepare, can't they fix it? Store energy, build shelters, beat the cold? It is the most human question there is, and physics gives it a firm, strangely dignifying answer: no. The second law is not an engineering problem. It is not a wall you break through or a shortage you plan around. It is the deep grammar of all doing. And every act of storing, sheltering, and fixing spends the very resource it tries to save. A civilization at the end of time could slow its fall magnificently, stretch its resources across spans we cannot write down, but it could not reverse the river, because it is made of the river. Whatever intelligence faces the last eras will face them the way every life faces its own evening, not by defeating it, but by meeting it well. And perhaps that is the final dignity available in this universe, to be the kind of thing that, knowing how the story ends keeps the lamps lit beautifully all the same. So let's gather the three endings one last time and say plainly where the evidence stands. The big crunch, the great collapse, the universe falling home into fire is possible only if dark energy weakens and turns, long dismissed, faintly stirring again in the newest data, but still a long shot. The big rip, the runaway tearing, the countdown that ends inside the atom, requires dark energy to strengthen, which is precisely what the measurements do not show. It remains the least likely death. And the big freeze, the slow fading, the 100 trillion years of stars, the long dark of the corpses and the black holes, the final silence, is the ending the evidence favors, the one written in the data we have tonight. If you want the single most honest sentence modern cosmology can offer about the end of everything, it is this: the universe will most likely die slowly, gently, and unimaginably far from now, and we are not entirely sure, and we are actively finding out. Every year, the telescopes sharpen the answer. The last page is being read, character by character, in our own lifetime. And what do we do with that? Here is the perspective I'd offer, the one this whole night has been quietly building toward. You now know, in more detail than almost anyone who has ever lived, how the universe ends. And notice what that knowledge weighs. Nothing you did today is diminished by it. Nothing you love is threatened by it. No worry you carried into bed tonight is made larger by it. If anything, every one of them is made smaller, gently, by the sheer scale of what you've been holding in your mind. The heat death of the universe is the least urgent fact you know. It asks nothing of you. It is scheduled for a date so far beyond all human meaning that writing it down is a kind of joke the cosmos plays on arithmetic, and yet knowing it changes something. The way knowing winter exists changes how a summer evening feels. The stars are temporary. The light is temporary. This bright, warm, crowded era, friends, mornings, music, rain, is the young universe at its best, and you are in it. Not at the end of anything, at the beginning of everything, in the first hour of the first morning, with the whole year of stars still ahead. Let me linger for a moment on the biggest number we've used tonight, because I don't want it to pass by as a blur of zeros. 10 to the power of 100, a 1 followed by 100 zeros, is the time scale of the black hole era, and it happens to have a name, a Google. It is a number with a peculiar property. It is larger than every count of physical things there is. Count every grain of sand on Earth, around 10 to the 20, every second since the Big Bang, under 10 to the 18, every star in the observable universe 10 to the 24 or so, every atom in the observable universe about 10 to the 80. Take that last number, every atom in every star in every galaxy we can see, and it is still short of a Google by a factor of 100 quintillion. There is nothing in existence you can counter Google of. The only place the universe uses numbers that size is in its own calendar. And that is what the patience of the cosmos looks like. A future so long that the total inventory of everything that exists is not enough to tick off its years. When you cannot sleep because tomorrow feels enormous and everyone has those nights, there is a strange medicine in a number like that. Tomorrow is one day. The universe has a Google of years and no appointments at all. Here's another quiet comfort hiding in the physics, one that most tellings of the heat death leave out. Nothing is ever destroyed. That sounds like a platitude, but it is a conservation law, among the most rigorously tested facts in all of science. Energy is never created and never annihilated, only transformed and dispersed. At the end of everything, after the last black hole has evaporated, all the energy that ever was, every jewel that ever blazed in every star, every calorie that ever warmed a living body, still exists, all of it. The heat death destroys nothing. It only spreads everything perfectly, evenly, everywhere, like an inheritance divided so finely among so many heirs that no single share can be spent. The universe does not end by losing what it has. It ends by finishing the act of giving it all away. There is a real difference between annihilation and rest, and the difference matters at the scale of the soul. The far future is not a void where the universe used to be. It is the universe, all of it, every scrap accounted for, lying evenly and forever at rest, not erased, completed. And it's worth noticing that endings are not new to the universe, that everything we treasure was purchased by an earlier ending. The first stars died, some of them in colossal explosions, and those deaths were not losses, they were deliveries. Every element heavier than the primordial gases, the carbon, the oxygen, the iron, the gold, was forged in dying stars and scattered by their ends. No supernova, no planets, no stellar death, no you. The sun itself is a second or third generation star built from the ashes of predecessors, and the Earth is, quite literally, a graveyard arrangement, old star death, gathered and warmed and set turning. This has been the universe's method all along. It ends things into new things. The age of stars will end into the age of remnants. The remnants into the age of black holes, each era the compost of the next. Right up until the final era, every single ending in cosmic history is also a beginning. The pattern only runs out at the very last page, and even there, as we've seen, physics cannot quite bring itself to promise that the pattern stops. If you want to bet on the universe's habits, the safest bet in 14 billion years of form is this: it has never once ended anything without making it into something else. There's a way to tell tonight's whole story as a single number falling, and it's worth hearing once, because it may be the simplest version of the truth there is. The number is the temperature of the universe. At the earliest instant, we can meaningfully describe the universe's temperature stood at figures with more than 30 digits. Heat beyond any analogy, hotter than the cores of all the stars that would ever exist, combined and multiplied beyond counting. Within 1 second, it had already fallen to around 10 billion degrees. After 3 minutes, cool enough at last for the first atomic nuclei to hold together around 1 billion. By the time the universe turned 380,000 years old and the first light broke free, the whole cosmos had cooled to about 3,000 degrees, the temperature of a candle flame everywhere, in every direction. And it kept falling. Today, after nearly 14 billion years of expansion, that same all-pervading warmth stands at 2.7 degrees above absolute zero. The faint microwave whisper we've met before on this channel, the heat death we've spent tonight approaching, is nothing more than the final entries of that one long column of falling numbers. 2.7 becomes 1, becomes a millionth, becomes a number indistinguishable from 0, never quite arriving. That's it. That is the entire biography of the universe told in one measurement. It began as pure fire, and it has spent every moment since then, every era, every star, every life, cooling down. We are not living in a warm universe that will someday turn cold. We are living partway down the longest exhale there is. And everything we love, chemistry, oceans, bodies, thought, exists precisely because the fire is no longer too hot and not yet too faint. Life happens on the way down, in the mild middle stretch of the great cooling, and we are in it now. One more reframing, and it may be the deepest one. We speak of the far future as the universe going dark and cold, as though darkness and cold were some foreign fate awaiting it. But look around tonight. Honestly, the universe is already dark, it is already cold. Averaged over its whole volume, the cosmos right now sits within a few degrees of absolute zero. The warm places, the stars, the sunlit mornings, this room are the rarest of rare exceptions, scattered pinpricks of fire in an expanse that is, and always has been, overwhelmingly night. You have been living in a cold, dark, almost empty universe your entire life, and it has been fine, better than fine. It has been beautiful. The night sky you love is the darkness. The stars matter because of the black they hang in. The far future is not a different kind of universe. It is this universe, with the proportions gently shifted, the exceptions rarer, the night deeper. If the cosmos as it will be sounds unbearable, remember that the cosmos as it is was always mostly that, and that you have gone out under it on clear evenings and felt not horror, but peace. The dark was never the enemy. The dark is where we keep the stars. And since we've spent so much of tonight in the deep dark, let me leave you with one bright detail from the late universe. Because the last age of stars will have worlds, and they may be among the most peaceful places that will ever exist. The red dwarfs, those small, patient stars that will carry the torch of starlight through the universe's long evening, have planets. We found them. Some of the nearest stars to us are red dwarfs with rocky worlds circling close, and a red dwarf's steadiness is unlike anything our sun can offer. Our star grows hotter as it ages and will die in 5 billion years. A red dwarf barely changes for trillions. A world in the warm embrace of a red dwarf could keep its gentle climate not for millions of years, not for billions, but for spans of time 1,000 times longer than the entire history of the universe so far. If life ever takes hold on such a world, and the universe has trillions of years of chances to arrange it, it would know a stability we cannot imagine. A sky with a soft, coral-colored sun that simply never changes. Seasons that repeat without drift for longer than all of cosmic history. Evening after evening after evening. Functionally without end. The deep future is not only loss. Somewhere in the long twilight of the universe, there may be quiet worlds under small red suns where nothing hurries, nothing burns out, and the sunsets outlast every number we used tonight. If the universe's morning belongs to drama, to blazing giants and colliding galaxies, its evening belongs to peace. The cosmos, like most of us, is going to spend its youth burning bright and its old age calm. And while we've been speaking of last things, the moon has one more small ending to give us. A strangely specific one, and it belongs to a future near enough to feel. Because the moon is drifting away from us, it is very slowly shrinking in our sky. And by an astonishing coincidence, perhaps the loveliest coincidence in nature, the moon at its present distance appears almost exactly the same size as the sun, which is why total solar eclipses exist at all. The 400 times larger sun sits 400 times farther away, and the two disks match, and for a few minutes the moon can cover the sun perfectly, revealing the solar corona like a silver crown. But the match is temporary. As the moon recedes, its disk narrows, and estimates suggest that in roughly 600 million years, it will have drifted too far to ever fully cover the sun again. There will be a last total solar eclipse, an actual final one, somewhere over some patch of the Earth, watched or unwatched, and after it, never again. 600 million years is a long time. There will be hundreds of thousands more eclipses before the last. But it puts a quiet frame around every one of them. Each total eclipse is one of a large but finite and dwindling stock, a limited edition the solar system is slowly discontinuing. If you ever stand in the moon's shadow, you'll be witnessing not just an alignment but an era in its long farewell. Beauty of the kind this universe specializes in, the kind that is passing, slowly enough to love. And lest all these last things leave the wrong impression, let me tell you what the universe is doing tonight, right now, while you drift. It is being born everywhere, still. In our galaxy alone, the great clouds are collapsing as we speak. The Milky Way kindles new stars steadily, year upon year, somewhere out there tonight. This very night, there are stars igniting for the first time, their light beginning journeys that will outlast every nation on Earth.
New planets are condensing right now in disks of dust around infant suns, worlds being assembled tonight that will still be young when the sun is a crystal. Across the observable universe taken together, stars are being born by the thousands in the time it takes you to fall asleep. Comets are rounding distant stars. Moons are raising tides on oceans no one has seen. The light of 100 billion galaxies is in flight across the dark at this moment, some of it aimed, by chance, at the exact place your eyes will be tomorrow night. This is what the universe is dying actually looks like from inside. Tonight, creation at full flood, everywhere, in every direction, with the ending so far away it cannot be meaningfully said to have begun. You are not falling asleep in a fading universe. You are falling asleep in a universe so busy being born that its death is still, after 14 billion years, little more than a rumor from the mathematics. Try one last thought experiment with me, the gentlest one of the night. Imagine you could watch the whole life of the universe as a time lapse, some impossible film shot from outside, one frame for every billion years. Press play. The first frame is fire, the Big Bang, the glow, the first stars igniting like sparks, catching in kindling. Within the first dozen frames, the galaxies assemble, collide, settle. Somewhere in frame 14, a single frame, the sun forms, the earth cools, life begins. Everything we have ever known flickers past too quickly to see, and the sun is already dying by the frame's end. The film runs on. The galaxies redden slowly, like autumn arriving over eons. The sky empties as the expansion carries the distant ones away. The light thins, frame by frame, gracefully, the way an evening does. By frame 100,000, the last stars are guttering, and then the film simply continues, frame after frame after frame of deepening dark, the remnants cooling, the black holes drifting, trillions upon trillions of frames of night, the movie running longer after its final scene than any story ever has. If you watch that film, I don't think you would find it frightening. I think you would find it what it is, a single, coherent, astonishingly beautiful event, a flash of light that opens into an endless, ever calmer dark, like a bell struck once, ringing longer and longer, and softer, forever. The universe is not a tragedy interrupted. It is one long note, still sounding, and we live inside the bright first instant of its ringing. And if all the eras and numbers of tonight have blurred together as you've drifted, good, let them blur. Here is the whole story once more, small enough to fall asleep holding. The universe was born in fire, and it is young. For 100 trillion years it makes stars. We live in the first sliver of that age, the crowded morning. When the last star fades, the universe keeps its remnants like keepsakes, cooling embers, patient black holes, for spans of time that make the age of stars look like a single breath. Slowly, Gently, over a Google of years, it gives everything away until all that was concentrated is spread perfectly everywhere, and the cosmos settles into a rest that nothing disturbs. It ends the way you are about to, warm, slow, and without fear. And it may not even be an ending. The last page is written in ink we cannot yet read, and every thinker who has stared at it longest keeps finding, hidden in the final dark, the shape of a possible morning. That's it. That's how the universe ends. You can set it down now. So, as we come to the end of tonight's long journey, the end of our walk to the end of everything, let's gather it all together one final time and hold it gently, the way you'd hold something finished and put it down. We began with the largest question there is: how does the universe end? And we found that science has real answers, not one ending, but a handful of candidates hanging on the nature of the strange dark energy that fills the sky. We watched the Big Crunch, the universe falling home into fire, the beginning played backward, buried by the data, now faintly stirring again as new measurements hint that dark energy may be slowly changing. We stood inside the Big Rip's terrible countdown, galaxies, then stars, then worlds, then atoms, and set it down again, reassured, as the least likely of the deaths. We met the strangest ending, the bubble that could arrive without warning, and found the numbers so absurdly, overwhelmingly on our side that it dissolved from fear into wonder. And then we walked the long road of the ending that the evidence actually favors, the big freeze, the last star born, the last light fading, the age of remnants, the slow evaporation of the black holes, and the final, perfect, painless stillness at the bottom of time. A universe that dies in its sleep. And on the way, something happened to the fear. It kept turning into perspective. The end of the universe is real, and it is so far away that every number for it breaks the mind that tries to hold it. The end of the universe is certain, and it is the very law that makes stars shine and hearts beat, the price of a cosmos where anything happens at all. The end of the universe is dark, and the dark was never our enemy. It is the thing we have always kept the stars in. And the end of the universe is an ending, and endings, as far as anyone has ever observed, are how this cosmos makes its beginnings. Thank you for walking all the way to the end of time with me tonight, through the fire and the tearing and the long, gentle dark, and back home again to a warm room on a young world under a sky still thick with galaxies. These are the best journeys to take slowly at the edge of sleep, when the mind is soft enough to hold the largest things without flinching. And I'm grateful yours came along. If these quiet explorations help you let go of the day, take a moment to subscribe and stay with us. There is always another vast, gentle question waiting in the dark, and we will keep meeting them together, one night at a time. For now, there is nothing left to do but rest. The universe has a Google of years ahead of it, and not one of its endings is your responsibility tonight. The stars are still being born,
The last one won't arrive for 100 trillion years. The sky outside is the first page of the album, the crowded, brilliant morning sky of a universe still close to its beginning. And you are one of the lucky ones who got a seat in the early light. Let the great clock wind down without you for a while. Let the river carry you. The cosmos is young, the night is warm, the ending is farther away than numbers can say, and you, here, now, are exactly on time. Sleep well tonight. The universe will still be young when you wake. Good night.